Hello, this is Yangqiao Yuzhou presenting FLamE, which is short for Few-Shot Learning from Natural Language Explanations. This is joint work with Yiming Zhang and Chen Haotan from the Chicago Human Plus AI Lab at University of Chicago. To start with, let's look at this QA example. The question is, David's eyes were like daggers at Paul when Paul invited his new girlfriend to dance. Can this be interpreted as David had two daggers when Paul invited his new girlfriend to dance? The answer is false, because David's eyes were not literally daggers. It is a metaphor used to imply that David was glaring fiercely at Paul. As we can see, explanations provide rich information about the task. Remember that we're interested in few-shot learning. Few-shot learning means that we only have a few training examples, so explanations have gained interest in assisting few-shot learning. However, research shows that the effect of learning from explanations remains mixed, because machine explanations are far from perfect. Therefore, this leads to the question of our interest: how can we effectively work with imperfect explanations? That's where we propose our few-shot learning framework to work with explanations, FLamE. Let's start by looking at the example from NLI. We convert the premise and hypothesis to the format of premise, question, hypothesis. So here the example is men playing frisbee in the woods. Question, is a group playing? The label set consists of true, false, and maybe, corresponding to the labels entailment, contradiction, and neutral. Let's first look at the case where we only use GPT-3 to conduct the task. We give GPT-3 the input, and we can ask it to generate the label first or generate the explanation first. These two paradigms are known as predict then explain and explain then predict. We find that GPT-3 generates the label with the highest probability, but they're not always necessarily correct. In particular, predict then explain generates the label without generating the explanation first. Whereas under explain then predict, the explanations can be wrong, which can mislead the label prediction. To address this problem, our idea is to combine GPT-3 with a smaller model to judge GPT-3 outputs. In the first stage of our framework, we use GPT-3 to generate explanations for all the possible label classes. So, if we set the label to be true, the generated explanation in this case is men are playing a game of frisbee. If we set the label to be false, the explanation becomes frisbee is not a type of game. And if we set the label to be maybe, the explanations become the men might be playing a game. In our second stage, we use the generated explanations from the first stage as inputs to our smaller model. In order for our smaller model, our judge model, to work with few-shot learning setting, we extend prompt-based classifier to be explanation-aware. This can be done by appending the generated explanations to the end of the input for the prompt-based classifier. The task is to predict the highest likely label for the mask token when we use explanations generated with different labels. As you can see here, the label with the highest probability among all the inputs will be taken as the final prediction. We find that FLamE beats all the baselines, including strong GPT-3 baselines. As you can see here, the best results are being circled out, and they're better than all of the rest. Taking a closer look at results, we find that prompt-based fine-tuning, which is the second stage, addresses the unreliable generation of explanations. We find that FLamE consistently outperforms only using GPT-3 across all datasets, regardless of whether we use GPT-3 Babbage or DaVinci. Recall that FLamE also has a GPT-3 component, so the difference in results corresponds to the effectiveness of the second stage of FLamE. In addition, stage 1 is also important for the success of FLamE. Recall that stage 1 generates explanations for all the possible label classes. This is important because generating explanations addresses the unavailability of test-time explanations. If we just train classifiers with explanations but test without, which means we do not have the GPT-3 component, then the performance is much worse than if we use FLamE. In fact, as you can see from the plot, the difference is at least 20%. Given the success of FLamE, we're also interested in studying why explanations are helpful. So we conducted an in-depth analysis, and we found that, surprisingly, the majority of explanations are not logically sound, while generating correct label-specific cues. Label-specific cues correspond to the phrases that often show up for certain labels. In the example here, the phrase "we do not know" is considered as a label-specific cue for the neutral label. We conduct probing experiments on the cues and found that they are the key to the usefulness of explanations. If you're interested in this analysis, we highly encourage you to come to our talk at ACL, where we will discuss the probing experiments in more details. So, in summary, we propose a few-shot learning framework, FLamE, to effectively learn from explanations. And we also provide an in-depth analysis on the utility of explanations. Thank you.